Armstrong number is such type of number whose sum of the cube of its digit is same to that number. What it's mean? Let's say 153. So if you check the digit 153, their cube summations is same as 153. So if Today we will create a program to find out a number is Armstrong number or not. First we have to understand what is actually Armstrong number. Okay, so Armstrong number is such type of number whose sum of the cube of its digit is same to that number. What it's mean? Let's say 153. So if you check the digit 153, their cube summations is same as 153. So if I take the first digit as 3, then 5, then 1, and make their cube and summations of all this cube value, then it will come 153. So if this type of number come, then that type of number is called Armstrong number. Now let's understand this logic with this flow. Then we will follow the same flow in our Eclipse program and execute the program. Okay, so first we have to create three variable n, r, t, where n represent the number, r basically represent to collecting the remainder of that number, and then t is basically a temporary variable which will collect the initial value that is basically entered by user for this n. Then another variable is needed to calculate the digit cube sum, and that is basically s. Initially we set s as a 0 value, then t is equal to n, that I told, the temporary variable t that will hold the initial n value. Then our loop start here. First we check n greater than 0. If yes, then it will go here and it will create or it will execute these three statements. First we will check remainder. So r is equal to the number, it's modulo by 10. So it will basically check the remainder. Then based on that remainder we will create the cube of that remainder and add that one with the sums previous value. So currently it's a very initial phase, s is equal to 0, but next time once the s will got some value, then that will be added again with the next remainder cube. Okay, and finally n is equal to n by 10. Okay, then it will go here, and once the n value is again greater than 0, it will execute the same statement, and these iterations will going on till this condition get false. And once it gets false, then we will check the summations of this digit cube or remainder cube that is basically same with the previous value that was entered, or very initial value that was entered by user for n, that was previously we collected with a temporary variable t. If both these are same, then we will print that this is a Armstrong number, otherwise it's not a Armstrong number. So let's check this flow with some value, then we will execute that one, or we will create a program for Armstrong number. Now let's check 153, this number with this flow. Okay, so first user enter a value that will be collected under this n variable, and that is 153. Then we set s is equal to 0, and finally this t basically a temporary variable that will be collect the n value that is equal to n, and that n is equal to 153. So basically t value is 153, right? Now it's check, is n means 153, is 153 greater than 0? So it's yes. That's mean it will first calculate the remainder, r is equal to n, that is 153 modulo 10. So 153 modulo 10 in the first iteration. So this is my first iterations. So in this first iterations, r is equal to 153 modulo 10. That's mean it will fetch the value or calculate the value of r is equal to 3, right? Now then s is equal to s plus r cube, right? So s previously it set as 0, so 0 plus r cube, r means 3, so 3's cube is 27, so 0 plus 27 is equal to 27. So now in iteration 1, s value will be set as 27, then n value will be n divided by 10. That's mean 153 divided by 10. So that's mean result is 15. So in my first iterations, r, s and n is something like 327 and 15. Now my n value is 15, so n is 15. It will go here and check is 15 greater than 0. That means yes. So again it will execute the step. Now in second iterations, r is equal to n modulo 10. So n is basically 15. So 15 modulo 10 is nothing but 5. Now s is basically s plus that reminder, that is r cube. So s previously was 27 and r is now 5. So 5 cube is 125. So s means 27 plus 125 is equal to 152. So in my second iteration, s is basically 152. Now again it's come here and n is equal to n by 10. So n previously set as 15. So now n is equal to 15 by 10. That's mean 1. Okay, so once n is 1, it will go here and check is 1 greater than 0. Yes. So that's mean now it is the time to execute the third iteration, and now n is set as 1. So now r is equal to n modulo 10. That's mean 1 modulo 10. So we will get again reminder as 1. Now the second statement, s is equal to s. So previously s was 152 and now 152 plus r is now 1. So 1 cube is equal to 1. So 152s then plus 1 is equal to 153, and then n will be 1 divided by 10, that is basically 0. So in my third iterations I got r is equal to 1, and based on this r value s is now 153, and then n I receive it by this calculations is 0. If n is 0, then it will go here and check is 0 greater than 0. No. So that's mean it will exit from this loop and go this way. Now it will check s. So what is the last s value? That is basically this s value in last iteration it's set as 153. So it will check is 153, that is s value double equal to t. So what is t? T you can see very initial time we said the number value, that is basically 153. So now s and t both are same. So s is basically 153 and t is also 153. So both are same, means it will go this side and it will print that this number is a Armstrong number. Now let's say in this calculation, if it's not equal to, that's mean the number inputted by user and the calculations of their digit cube summations is not same, then it will print this is not a Armstrong. So this way you can create a program to execute your Armstrong number. Okay, so let's check the same thing in a Eclipse. So I have opened my Eclipse and I have also created a Armstrong number class under the same package com.demo.loop, and this is my main class. Let me double click here, and what is our aim? Our aim is to create a program so that whatever the number entered by user, that need to be checked is it a Armstrong number or not. So if I go to the flow again, so first we have to create three variable nrt. So create the same as an integer nr then t, and another variable that is basically s with initial value is equal to 0. So make this s is equal to 0, then exit with semicolon. Okay, now you have to collect the n value, right? So how we can collect that one? Definitely using scanner class, with the help of scanner class. So first you have to instantiate scanner class. So we know the syntax. Scanner sc is equal to new scanner, and under bracket from where we have to take the input system dot in. So take this one, system dot in this way, and then semicolon. Now you can see the compiler error, and you know why this is, because we have to import java.util package. Now my scanner class instance is ready. Now user have to give an input that enter a number, right? So create a system.out.println statement and give a statement enter your number. So once user enter that number, we have to collect that under n variable, right? So we have to write the syntax like n equal to sc, the instance of scanner class, then as it's an integer, so dot next int. Okay, so once I did that one, that's mean once any value entered by user, that will be collected under n. Now go to the flow again. Now you can see here I have initiate s as 0. Now the next we have to use the temporary variable t, and that value should be the entered value n. So user already entered the value and that is collected in n. Now under this temporary variable t, where we have to collect the n value, so that in last phase we can check the exact value with the digit cube summations, right? Now my this step is done. Now it's time to create the loop, and which loop we will use, because we don't know the exact iterations count, so definitely we will use while loop. So let's create a while loop with conditions n greater than 0. So make a while loop, and here n greater than 0, and here your loop start and then end here. And under this loop we have to create three statement: r is equal to n modulo 10, so make the same thing, r equal to n modulo 10. Then the next one, s is equal to s plus cube of that reminder, so s is equal to s plus cube of that reminder, means r into r into r. You know that star is nothing but denote the into sign, right? Now my second statement is done. The third statement, n is equal to n by 10, so create the same thing, n is equal to n by 10. So my logic is written under this loop. Now make sure to save it with control s. Now if your logic is properly executed and after number of iterations, once these conditions get false, it will go this way, right? And here again we have to create a statement, but this is basically just once it fail this condition, that's mean it will exit from this loop. So once we exit from this loop, while loop start here and end here, so after that we have to create another condition, is s equal to t. So here we can create a if condition, is s mean the summations we have collected based on this logic is double equal to, we know in if we use double equal to sign, is the temporary value. What is this temporary value? Very initial phase, whatsoever the value entered by user, that is collected in n. So if these are same, why we make this temporary value? Because you can see every time we are overriding the n based on the iteration, so n value definitely will not be the same which was entered very previously by user, right? So that's why very initial phase we store that n value in a temporary variable called t. Now we will check the summations of s, that is basically we collected based on the iterations, is same with not n, basically t. Now if we enter here, so there my logic is, if s double equal to t, then it will go this way and it will print it is a Armstrong number. So make here system.out.println and print it is a Armstrong number. And if it is false, that's mean is not equal to t, that's mean in else conditions print the just reverse statement, just copy paste it and say the it is not an Armstrong number. Okay, so now you can see that I have use the same logic that is written on this flow. First we have created few variable nrt, then s with initial value 0, then instance of scanner class to collect the value of n, then we use this t is equal to n, t is equal to n, then our condition n greater than 0 with while, then three statement r is equal to n modulo 10, s is equal to s plus cube of that remainder, and finally n is equal to n by 10. So you can see here these are the three statement under while loop. Finally, once this is exit from this loop, we will check s double equal to t or not. If it's yes, then it is an Armstrong number. Otherwise, else part we are printing it is not an Armstrong number. Okay, so this way you can create a Armstrong number example or program. Now let's check that one. So first you save this program using Control S, then run this by click on this button. Now let's check a proper Armstrong number, that is 153. It is a Armstrong number. So if I enter here, it should print that it is a Armstrong number. So yes, you can see here it's give me that it is an Armstrong number. Now run it again and let's make another number. Instead of 153, it's a 154. Is it Armstrong number? So it says no. Why? Because 1 cube plus 5 cube plus 4 cube is not equal to 154. That's why it is given it is not a Armstrong number. Let's run with the exact Armstrong number again, like 370. 370 is an Armstrong number. So if I enter here, you can see it is an Armstrong number, because 3 cube plus 7 cube plus 0 cube, that is 0, all the summations is basically 370. Similarly, another Armstrong number, let's say 407. So if you check this one, it says it is an Armstrong number. So this way you can create a Armstrong number. And again I am saying the same thing as I repeat in our last few classes, that if you understand the logic of this flow, then you can blindly follow the same step in your Eclipse program, and that will execute and give you the expected result.
I believe this video has helped you to understand about the topic. Thank you for watching. Please do subscribe, click on the bell notifications and select all so that you don't miss any video from this channel.